Okay, so today we're going to be explaining the test. And for the first one, it's asking us to take the integral of x3 ln x dx. And how we do this is we have to do integration by parts. In order to solve this, we have to use this as our u value because we can't integrate ln. We use this as our dv value. We know that the formula for that is u v times du. So we rewrite this, and we can say ln of x is equal to x4, which is the integral of dv, x4 over 4 minus the integral of the derivative of ln x is 1x. The integral into not integral, and the v value is x4 over 4. You put these together, this will convert to x3 over 4, and you integrate that, and you should end up with this value after integrating everything and adding it together of 1 over 4 x to the 4 ln x minus x4 16 plus c. That's number 1. For number 2, it's asking us to integrate 1 over x squared minus 7x plus 6. Here we have to do partial fraction decomposition. So we can rewrite this as 1 of x minus 6 x plus 1. And after we do that, we can rewrite this as a plus b of x minus 6 x plus 1, not plus 1, minus 1, sorry. Rewrite that, plug those values in, and then from here we can integrate. And once we integrate, we should get this value of 1/2 ln x plus 1 plus 1/2 ln x minus 1 plus c. Alright, for the third one, it was asking us to find the integral, the volume using the disk method. And we know that the volume using the disk method is the integral from the lower to upper of pi of f of x to dx, right? We know that f of x here was x, so we can rewrite this as pi is equal to x squared dx, 0 to 2. And once we integrate that, it's super simple. This goes to x3 over 3. Plug in that, it goes to 0, plug in that, and we should get, I believe, like 8 over 3. There you go. Okay. In number 4, it's asking us to find the sum when n goes to infinity of -1 n over 2 n minus 1. And in this case, you see here, we can do something called the alternating test series. Why can we do this? Because there's a negative sign here. So we automatically know that whatever value we plug in n, it will go from positive to negative, positive to negative, positive to negative. So the formula that we use is we use a of n plus b of n, b n plus 1, right? And in this case, our b of n is this, and our a of n is this. So we rewrite that, and we plug those values in, and we can see that it converges. Okay. For number 6, it's asking us to do the Taylor series to the third polynomial of f of x when it's equal to ex at a center of point 2. So right now that's irrelevant. Right now what we have to do is actually do the Taylor series of this. So we know that e of x with the Taylor series is this equivalency of saying 1 when taking the derivative of plus 2, or x, I'm sorry, plus x plus x squared over 2 plus x3 over 3 factorial, right? And if we plug in the values of 2 here, so we can say 1 e is equal to 2. This goes to 0. When e is equal to 2 of x, it's 2 of x to 0 plus x2, which is also 0, over 2. And as you see, it will just keep going to 0. Okay. For number 7, it's asking us to find the ratio test. I'm sorry. We use the ratio test here. In this case, it's asking us to find the interval of convergence, if there is one, which we already know there is here. And in order to do that, we have to apply the ratio test. And we know that the ratio test is a of n plus 1 over a of n, right? So for our a of n, we plug in this value plus 1 to every, there's one here too, to every value that we see. Why do we do this? So we can cancel it out. So once you do that, and I'll do it really quickly, a of n plus 1, x n plus 1, n plus 1, n plus 1. Once we do that, we can rewrite this equation, because we have to rewrite a of n. Instead of writing here in the denominator, we can flip it and multiply it. So that's what we'll do here. 2 of n, negative 1 n, x of n. And here, as you see, we have common variables. We can cancel, 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 cancel. And we're left with negative 1 of x over 2 times 1 from here. This can cancel. So once we do that, all we have to do is just see here that here in the denominator is our radius, and it converges at 2. In our interval, we can either plus or minus. In our case, our plus or minus is either x. So x is negative x 2. So you can either move this here or not. So our values would be from x when it's equal to 2 or negative 2. Okay. So here, this question is asking us to find the integration of 1 over 4 plus x squared dx, right? And we have to recognize that this is a form of trig identity, where if we write this, we can say 2 plus x squared. And we know that a plus b square rooted is the equivalency of saying secant, right? So once we say secant, we apply u sub, because we can't get rid of this. So we apply u sub, and we know that u here, same as saying 1u, and the du of that is this. So we can say du over u, or ln of tan u plus secant u, right? And now we can distribute the ln, and we can rewrite this once again saying ln, using trig identities, ln tan of arctan of 1/2 x plus secant arctan. So as you see here, we can cancel these. We can rewrite this as ln 1/2 absolute value of x plus, we can finally plug this u back, 4 plus x squared. There. So in this question, it's asking us to integrate this. The thing is, and apply these values. And when we integrate this and apply these values, we have to use power series. And rewrite this as negative 1x of 3 to 0. If you plug in these values of 0, it cancels out. And of 3, negative 1/3, you have to flip it back. So we know that this series converges. Right? Okay. So now in this question, it's asking us to rewrite r equals 1 plus cosine of theta. And what we do here is we sub r and we apply it as u. And we can move this here and say negative 1 is equal to cosine of theta. And we know from our unit circle that negative 1 is of cosine of theta can either equal 0 or pi, right? So now we apply our formula. And we know that the formula is 1/2 integral from lower to upper, which we just found, of 0 to pi, of the r, which is 1 plus cosine, 2 cosine, no, not 2 cosine, sorry, that was a mistake, cosine theta squared. Okay. So now when we do that, we can rewrite this equation, and we can write it as pi over 0, taking out the constant of pi here, pi over 2, pi over 0 of 1 plus 2 cosine theta plus, since we distributed this, plus cosine squared. And we know that this is an identity, also known as right? We plug this in, and once we integrate this, we will get a value of 3 over 2 x plus 2 sine x plus, or theta, sorry, plus, Jesus, right? And if we plug in 0 for theta, all of these will cancel out. And if we plug in for pi, for sine, they both cancel out. So we're left with this, 3 pi over 2 as our answer. Okay. Now, see, okay, it's asking us to prove from 4 to 0 it's asking us to find the arc length of the surface area, and we know that the bounds that we're given it from 0 to 4. How do we know this? Well, we're given those intercepts of 0 to 0 to, I believe, a random number to 4, and these are our intercepts. We can apply them to our bounds, and we know that the arc length formula is 1 plus f of x squared dx. In our case, f of x is y, and we square it. We can rewrite this as 4 over 0 of 1 plus y dy. And we are allowed to leave it like this. And that is the arc length formula. Okay. So for number 14, it's asking us to integrate the cosine from 3 to 3.1 of cosine x squared. And in order to do this, we can either do the trapezoidal rule or we can actually attempt to integrate this. And how do we integrate this? Well, we rewrite this as a constant. Pi over 2, constant of c of 2 of pi of 3 over 1 and 3. And once you calculate this in your calculator, you will get that the equation goes to 1.253. Okay, for number 15, it's asking us to find y prime plus y, well, not plus, minus y is equal to 16, right? And we know that in first order of linear differential equations, we can rewrite this 16y dy dx. And we want to move around our y's. How do we move the dy to dy? You times this here, y, times this here. You're good. dy dy, and it cancels out. So now we're left with y is equal to 16 dy, right? Move this here and we can say 16 minus y is equal to dy. And after you do this, now we know that our dy or dx, derivative of x, is equivalency of negative 16 plus y. And we know that our integrating factor here is used as e. So once we rewrite this, we can say that y is equal to negative 16 to e to the x plus c. Okay, for number 16, it's asking us to find r5 cosine and rewrite it in triangle, in rectangle formula. right? And we know that this equation can be rewritten as this equation plus y squared is equal to r squared, right? This is the rectangular equation. Well, not the rectangular equation. Once we cancel this out, then it will become the rectangular equation. But for now, we'll apply our numbers. X squared minus 2 of 5 over 2. How do we have 5 over 2? Because our r is 5 cosine theta. And once we distribute this and we move this down, we will get that. 5 over 2, x plus 5, 2, plus y squared equals 5 over 2, 2. And once you simplify that, you'll get your answer. So moving on from number 17, x equals 2t minus 3, this y equals 3t plus 1. We can rewrite this equation as we already know that when x squared plus y squared equals 1, we have our x value here and we have our y value here. But it's not perfect yet because we have to separate the t values. So what do we do instead? We rewrite this, and we can rewrite it in such a way where we can say x plus 3 is equal to 2 plus y plus 1 equals to 3. And we plug that value into this formula. So we can say once again x plus 3 minus 2 is 2 plus y plus 1 minus 3 squared. 1 squared. Now, if we really want to be cute, we can put it into common denominators, and it'll go to 6, so it'll be like 2x plus 9. 3x plus 9 is plus of 2y plus 2 squared is equal, and once we factor this out and we times it by 6, we can say it's equal to 6. And then from here we have a rectangular formula. Alright, now going into the last question, we can say that 0.5, it's asking us to integrate 0.5 cosine square root dx. And how I did this is I applied u sub. And once I applied u sub, I knew that once you write cosine of u du, it also can be written as a trig identity, which is sine u du is equal to negative cosine u. And once we have these values, we can rewrite it once again to say 2 is u sine of u minus cosine of u from 1 to 0, since we've been using u sub. Now that we applied these new ranges and domains, we can convert it, simplify, and apply our numbers, and we'll be left with 0.324. Okay. Now for our last test, it's asking us to prove that the interval of convergence is from negative 1x, negative 1, 2x, to 1, Let me write that again. So now we can say that this n plus 1, and we see this here, and we can automatically say ratio test of a of n plus 1 is equal to a of n. And once we do that, we can simplify this equation. We'll be left with 1 over 1, well, x over 1, 1 being our interval of convergence, or also known as our radius. We can apply x here, and when we move it around, we can either say it's equal to negative 1 or 1. That's my video.